Kindly fill in the attendance form provided in the chat box. Before we start, let us enjoy the montage video. Welcome to the third keynote speech session for MICON 2022. I am Ms. Nurashikin binti Amir Hamzah, and I'll be chairing this session, which will run from 9 a.m. until 10 a.m. This morning, we have Associate Professor Dr. Muhammad Hanif bin Mat Saad as our third speaker at our conference. Associate Professor Dr. Muhammad Hanif Mat Saad's passion is in R&D and commercialization of intelligent systems. Dr. Hanif and his team of dedicated engineers and system developers has successfully designed, developed, and implemented more than 50 desktops and cloud-based intelligent systems in various domains, including manufacturing, environmental monitoring, education, energy efficient intelligent building, and healthcare. For government agencies, MNCs, and SMEs in Malaysia, Singapore, Thailand, UAE, Bahrain, and Qatar. He is currently an associate professor and researcher in UKM, where he leads the Kaiser Complex Events Processing Platform Development Team, an industrial-grade desktop and cloud-based platform that can be used to develop integrated intelligence systems for industrial applications. He is also the current Deputy Director of the Institute of IR 4.0 UKM and the Technology Advisor to Enometrics Solutions Sdn Bhd and Al Dawuda Chulia Middle East Co. Qatar. Dr. Hanif is the winner of Mostis Emerging Innovator Entrepreneur Award for Malaysia's Commercialization Year 2016, MCY 2016, UKM's Bitara Pengkomersialan Award 2016, and UKM's Anugerah Khas Quality Pengkomersialan 2014. Ladies and gentlemen, Dr. Hanif will be delivering his speech on IR 4.0 and sustainable engineering for 45 minutes, followed by 10 minutes for Q&A. Before we get started, please turn off the GMeet mic. If you have questions, please keep it until we reach the Q&A session, or you may post it in the chat box and it will be addressed during Q&A session. Let us welcome Dr. Hanif.
Thank you, Madam Chairperson. Can I share my screen?
Yes, Doctor,
Okay.
please.
Can you see that?
Not yet. Okay, we
Okay.
can see it now.
Okay. Thank you. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh, and very good morning to everyone. Uh, First of all, I would like to thank the organizer for inviting me for this session. As mentioned just now, my name is Muhammad Hanif Masaad. You can call me Hanif. And just to clear up things that I would like to thank Madam Chairperson for the introduction just now. And just to clear up things, those are the things that we did in the course of the research and development work in the universities. And I'm not the only person who's doing it. I'm leading a team, so I have my team members from my institute, from my department and faculty, and also from the startup company that I helped to form, which is Innovative Solutions Neighborhood. So without their contribution, this will almost be impossible to be achieved. And I would like to acknowledge that contribution to everybody that has supported me all these years. For today, I would like to discuss and share some experience with everybody here on IR 4.0 and sustainable engineering. I hope that this is something that we can share and appreciate. If you have anything to add or you think something is not right, just let me know, because I'm very sure that everybody in this room right now is an expert in their own field, and I'm here just to share my experience and whatever some small knowledge that I know for the benefit of everyone now. Okay, for today, I will discuss and share about IR 4.0 and sustainable engineering. So how IR 4.0 can assist in the sustainable engineering. So this is basically my hometown lah. I'm not saying that this is my hometown. This is Alostar. My hometown is somewhere after these Rocky Mountains you see there, and it looks very serene. Very very cool and calm as compared to where here in Bangi right now. It's very very hectic. And then I would like to live in a place like this, whereby we can say that the population density is less, and also everybody has time for him or themselves or for their family, as compared to what we are seeing in this case. This is basically in Hong Kong. Very lucky for us in Malaysia to be able to have a situation like the previous picture that I showed just now. But in this kind of situation, well, this is what they have, and they have to manage it and somehow make this environment livable and attractive and livable for everybody. But how this can be implemented, of course, it will need a lot of planning and also help from the technology. Okay, and we all know that the urban population, this data is based on 2014. The world urban population is growing, and effectively the world population is also growing. We have about 4.5 billion people in 1980s. We have about 7.4 billion people in 2014. We are estimated to have about 2050, we have about 9.7 billion people. And the world that we are living in, the earth that we are living in right now, is estimated to have the capacity or the capability to support up to 10 billion people only. So sustainability is a very big issue, because when there's a lot of people in this planet, there'll be a lot of requirement for consumption. That is our basic need. Basically, we need to eat. If we don't eat, we die. Okay, so when you need to eat, we have to have food, and you have to have food. You have to generate food, to cultivate them, to rear some animals for us to consume, and so forth. To commute, to travel, to work, we utilize energy, and energy produces carbon and things like that. So in order to solve this or to cater for this, the United Nations, as everybody know, has set up these Sustainable Development Goals, 17 Sustainable Development Goals, to transform our world. And the target is in 2030, at least most of these sustainable goals is already achievable in 2030. So we don't have much time yet to, we don't have much time left to fulfill this actually. This sustainable goal to handle this situation so that our living can be as you know, as comfortable as possible in this earth, the only earth that we have currently right now. Well, that's why there is a need or a race, the race of need for sustainable engineering, which is basically just a process of using resource in a way that does not compromise the environment or deplete the materials for future generation. We know that we need to cater for 9 plus billion people by 2050, and the world can only accommodate about 10 billion people only. And we have to find ways to make this sustainable. And because of that, the common cause within the world of sustainable engineering is basically, if you look at it, the first one is food production and preservation. That's why I emphasize on food, because food is the top of the chain. We need to the istilah is kenyang lah. We need to have a adequate food first. Then we will talk about our. You need to have adequate food. Then we will talk about nice food. Then we can talk about transportation. Then we can talk about work. Without food, we cannot survive. So food production and preservation is very important, top of the list for the sustainable engineering. Then we need housing and shelter. Then we need to manage our waste, okay, in a sustainable manner. Then we also need to reduce the pollution. We need to manage the water supply. Then we goes to energy development and consumption, transportation, restoring the natural resource environment, and finally improvement in the industrial process. So the list is sorted in terms of the priority there. Food is number one. Okay. Right. So we have sustainable engineering, and this approach is a little bit different compared to the traditional engineering that we are previously so accustomed with. Okay, for traditional engineering, we consider object and process. For sustainable engineering, we consider the whole ecosystem. We consider the whole ecosystem. We are not only want to fabricate something, we want to fabricate something without damaging the environment, for instance. So not just producing the object, producing a product, or doing the process, executing the process, but we are considering the impact of doing that, of producing that as well. On traditionally, we will focus only on technical issues, but for sustainable engineering, we definitely consider both technical and non-technical issues synergistically. Okay, we solve the immediate problem with traditional engineering. Sustainable engineering, we try to solve the problem also for and solving it for the infinite future, if possible, forever lah, as long as we live in this earth or in this world. And we consider only the local context for traditional engineering. For sustainable engineering, you have to consider the global context. What you do here might affect somebody else in other country. You throw away radioactive water in the sea, our neighboring country will get affected. So those are the things that we have to consider. And usually for the traditional engineering, you work in silo. Means that I produce my products or process. Political, ethical, societal issues, somebody else will do it for me. But for sustainable engineering, there is an acknowledgement that this needs to be addressed while the problem is being solved. And you look at it, it's something like being a cognizant engineer or a mechatronic engineer. If you consider some, if in an analogy a little bit different than this, I mean sometimes you have mechanical engineer, you have doing mechanical product, electrical engineer doing electrical product, or programmer IT doing controls, things like that. They work parallelly, concurrent engineering approach, as compared to mechatronics engineer, where mechatronic engineer is somebody who's cognizant in the three main domain, and while developing a product, you can go along with that. Okay. Right, but the same applies for sustainability approach in engineering. Of course, the focus is now on sustainability lah. Right. For instance, this is an example that is quite interesting. This is by Dutch designer Dan Rozengaard. He built and developed the world's first smoke tower in Rotterdam in 2015. What is a smoke tower? It's something like a giant vacuum cleaner. You put it in city, not in your house. In our house here in Malaysia, we have Koei. I also have in my house Koei. During the COVID breakout, previously a lot of people bought Koei. They can filter air and take out the virus. This as the the producer said. But this guy developed this vacuum cleaner and put it in city. It can suck polluted air, clean it, and then ionize through ionization, and then release it back. So at peak performance, it can clean around 30,000 uh, cubic meter of air hourly. So this is an example of sustainable engineering product, basically not the process itself, but something to do with sustainable engineering. And the good thing is that recently this inventor did something very interesting. He filtered the carbon from the giant vacuum cleaner. So from the filtered carbon, they take it and they turn it into jewelries. And as we know, perhaps in the near future, this also can be perhaps in the near future, this can also be be used to produce diamonds and things like that, because these are just carbons. They suck the carbon from the air. Okay, the principle of sustainability and sustainable design and sustainable engineering guides us on how to do sustainable engineering. This is much like what we have in our government or in policy. For instance, our government says that we are going to implement a policy on what the health minister said yesterday. He said that we are going to introduce um, generational end game, if I'm not mistaken. The term is generational end game, whereby those people born after, if I'm not mistaken, those people born after 2007, they will no longer see. He wants to abolish smoking altogether. Now, that is his policy. Once the minister has stated the policy, the implementation of the policy is going to be executed by the respected ministries. They will issue the guidelines. The Ministry of Health will issue guidelines and circulars how to handle these kind of things. And the circulars will then be relegated to the hospitals, to other agencies to implement. So the same goes for sustainable engineering. We need to have a guiding policy first that will serve as as a source of power, as a source of reference for our conduct. So we have the principle of sustainability and the sustainable development goals by the United Nations, and then we water down to how do we implement the sustainable design, and then once we have a sustainable design in place, then how to implement the sustainable design, we will utilize sustainable engineering. And from the sustainable engineering, we would require the technologies that will allow us to implement the sustainable design of a process or of a product. And this will impact the lifestyle. So the flow goes from the guiding principle to the design, to the technical details, to the implementation tools. Right. So we are talking about IR4 and sustainable engineering. So this is where later we can relate how the IR4 can assist in enabling sustainable engineering to fulfill the sustainable design requirement. So I am taking this case study. This is basically on the engineering sustainability of pavements. The author looks at how to develop a sustainable pavement. So he considers the economy, the initial cost, the user cost, the agency cost, and considers the environment. What does it has the impact on the greenhouse gas emission, fuel consumption, aggregate demand, binder demand, and so forth. And also from the engineering point of view, how these are going to be implemented, rutting, fatigue, thermal cracking, and so forth. Now, if the three elements here is considered, then we can see that the design for this particular product follows the sustainable engineering principle. In fact, for some other researchers, they would include another circle, which will be people. But to me, if you consider economy and environment, basically you're considering people already. Engineering is just on the technical side, the economy on the system, on the longevity and sustainability of the running of the project itself, and the environment is to consider what is the impact on it has on the surrounding. So if you consider all this, then basically we have achieved sustainable engineering or sustainability there. So the three E's of this sustainability will be the economy, the environment, and the enablers. The case for this particular researcher, because he's looking from an engineering point of view, a civil engineering point of view, so he puts that engineering. I put here enablers. Why? Because sometimes there are projects or there are products which does not use physical engineering per se, but we have perhaps software engineering and also the tools that is required within the software engineering vicinity. So that's why I replace this with enablers. This is the three P's of the sustainability. Right. So if we implement sustainable engineering, of course, we have a lot of benefits in terms of savings, in terms of asset values. But first and foremost, the benefit is definitely that we are able to make the world as a better place to live in. That is our objective. Sustainable engineering, we want to make the world a better place to live in. We don't want to deplete the resource. We want to let our children, our next generation, to have a world that is as good as what we have right now, or even better, compared to we don't want to give them something that is not habitable, that is not good to live. And part of the I'm part of the initiative by the Yayasan Samdabi. We have this what they call as Yayasan YSD UKM Sustainability Chair in UKM, and we try to look at the sustainability of the palm mill operation. We have the zero waste technology pilot plan, which utilizes the sustainable engineering approach and also the circular economy approach. Right. So this pilot plan is sponsored by Samdabi, basically owned by Samdabi, operational since 2017. This chair has been in UKM since more than 10 years ago. So this pilot plan was developed along the chair's activity. The feedstock to the chair is to the pilot plan is liquid and solid biomass from the palm oil mill. 5 integrated trust area means that in our YSD sustainable engineering sustainability chair, we have 8 trust area: IoT, data analytics, intelligence system, climate change, and so forth. So a majority of the trust area is involved in the Yayasan Sendabi pilot plan to develop it. And this pilot plan has zero waste. We recycle and reuse the water that is utilized in this plant. We used for the plant, the feedstock, we use the solid biomass from the palm oil mill. I mean the waste that was produced from the palm oil mill. Once they press all the palm oil, the fruit bunch that is not used anymore is used to generate electricity there. So this is the technological elements within the pilot plan. But we are not implementing the IR 4.0 yet for this particular pilot plan, and we are looking into implementing it in the near future. But this is just I want to share some example or experience on the sustainable engineering that we have been doing with UKM lah. Now we move from the sustainable engineering to Industrial Revolution 4.0. I think everybody has heard about this so many times already. It has been here for quite some time. It's not something new, and most of you are very familiar with it. I just want to share some knowledge about the Industrial Revolution 4.0. Feel free to point out to me if I do any mistake, things like that. One of the most famous quote on IR 4.0 is given by Professor Schwab. We stand on the brink of technological revolution that will finally alter the way we live, work, and relate to one another. Okay, the scale, the scope, the complexity, the transformation will be unlike anything humankind has experienced before. He wants to emphasize that the Industrial Revolution 4.0 is not something just you say it for the sake of for IR 4.0 or Industry 4.0, something like that. It is true. The transformation is big. The impact is big. If we don't engage with this transformation, we are going to be left behind. In the current situation, in the current world, it's not a world of the big fish eating the small fish. No longer that nowadays. It's the world of fast fish eating slow fish. With all these what they call disruptive technology, you don't have to have a very big company to disrupt an industry. It can start from a very small, agile, fast company or startups to introduce something that will ultimately disturb the business or the process, and those who are not able to adapt to the changes will be left behind. The best example would be in our country, Grab lah. Grab and our normal taxi kan. So basically, when Grab started, taxi services were already there. We have a number of companies operating taxis. Grab started just for a small company with some grants from FCAP, 100,000 plus. It's just a ride-hailing operation, and then they expand so much that nowadays the taxi is under very heavy pressure from Grab, and Grab has, as we all know, has transformed from just ride-hailing company into everything, a super app. You can order food, you can order a lot of things, even you doing payment with Grabs, and this is the case whereby not the big fish eating the small fish. The big fish will be the taxi previously. Small fish will be Grab when they started initially. This will be the case of the fast fish, which is Grab, eating the slower fish, which is the taxi industry in our country. Okay, this is an example. So if we don't adapt to this, we're gonna be left behind. Okay, so and everybody knows that we basically have up until now, there are four industrial revolution. The first industrial revolution, basically on the mechanization, steam power and water power, formally transforming from using human in the operation into utilizing machines for the operation. Then we have the second industrial revolution, mass production, and electricity comes in, whereby practically made popular by the Ford car factories, because they wanted to produce more car so that a lot of people can afford that. And then the third industrial revolution is basically on the utilization of electronic and IT systems and also automation. And the fourth industrial revolution is what we have currently, is the imaging of the cyber physical system. Now, these are some of the elements in the industrial revolution. But if I were to summarize it, I would say that the first industrial revolution is on mechanization. Second industrial revolution is on mass production and electricity. The third industrial revolution is on automation. Okay. And the fourth industrial revolution, basically the underlying technology is connectivity. You don't talk about the fourth industrial revolution without good connection. Okay. Automation is already there during the third industrial revolution. It's already there. The timeline is basically, you start with 1940s, automation is already there, robot is already there. Okay. You want to compare with the fourth industrial revolution, the thing that is basically making them different is connectivity, and in this case in particular is the internet itself. Internet and connectivity. Without connectivity, there will be no industrial revolution 4.0. So these are the gist of the spirit or the underlying technology which moves the industrial revolution from one industrial revolution to another industrial revolution to another industrial revolution to another industrial revolution. This is important. Why? Because there are some people who are talking about industrial revolution 5.0, IR 5.0. So what are the case for IR 5.0? And in fact, if we look at Japan, they're looking at society 5.0. Later we'll talk about that. So in order for us to move from IR 4.0 into IR 5.0, theoretically, we need to have some groundbreaking technologies that can be implemented. And that is something that we have not seen or forecast to be happening in the next future, except for perhaps quantum computing. I would think that if quantum computing somehow find ways to have mass acceptance, then we will move from the IR 4.0 to IR 5.0. But there are also initiatives by the the Japanese government. They don't say IR 5.0, they say Society 5.0. But there are initiatives from in the European country to put sustainability into the elements of IR 4.0, and that will make IR 4.0 transform into IR 5.0. But some researchers, they don't agree on that, because there is just an evolution. It's not a true revolution. We're talking about revolution, not evolution. So you just incorporate sustainability, there is an evolution only, because the underlying technology does not change yet. Okay, there's a very mass shift of technology behind mechanization, electricity and mass production, automation, and then here is connectivity. So what's next? So I don't know. We are not seeing that for the timing yet. So this IR 4.0 is a tectonic shift in the way we live, we work, and live. So this tectonic shift is the Industrial Revolution 4.0. The way we work is the Industry 4.0, Agriculture 4.0, Office 4.0, whatever 4.0 you want to attach with. It utilizes the basic or the framework of IR 4.0, then we can call it Industry 4.0. If you implement all the elements or several of the elements of IR 4.0 in your, let's say, house, perhaps we can call that House 4.0. And we live. So the way we live ni, we don't call it Society 4.0, because why? We want to show that ultimately the human factor must be put into the utmost consideration. That's why the Japanese government introduced Society 5.0, and that's why the number is a little bit higher than the rest, because the emphasis is there for the society. And this is where some of the researchers in the European nations, they are pushing towards sustainability into IR 4.0 to upgrade it to IR 5.0. But that is just a suggestion. I don't know whether it can go or not. Okay, so Industrial Revolution 4.0, all this, this is the framework, the basic framework. The Industry 4.0, Agriculture 4.0, Office 4.0, and the rest of the 4.0 things are the implementation of that particular framework for particular industries, and Society 5.0 as the guiding principle for all of this. Whatever the technology is there, whatever the technology that is available, it is there to serve human. So human must be on top of the change. Okay, right. Basically, Society 5.0 was introduced by the Japanese government. So this IR 4.0, they started initially as Industry 4.0. When a group of researchers led by Professor Wolfgang Waschler in Germany, they were asked to find, to design, to identify the key elements that will make German manufacturing industries the top of the world. So this group of scientists and researchers, they come up with a number of things, with a number of elements that needs to be incorporated into the industry, into the manufacturing industry, so as to make sure that the manufacturing industry in the German companies become world class, right? So they come up with the term Industry 4.0, the German Industry 4.0. They were the one who first coined it in 2011. And also Professor Wolfgang Waschler also mentioned about IR 4.0, but very, very briefly, something like Industry 4.0 leading towards IR 4.0. So it's not right to say that Professor Schwab is the father of IR 4.0. What happened is that Professor Schwab picked up this report and also all the initiative done by the German government, and he popularized it. He's currently the president for the World Economic Forum, and he popularized the terminology for IR 4.0. Industry 4.0 by this team, IR 4.0 by Professor Klaus Schwab, and then utilizing the principle derived from here, they implemented on the Agriculture 4.0, City 4.0, Building 4.0, and the rest of it. Okay, so that's the main difference between the two. Okay, so these are the fathers of this Industry 4.0 and also in IR 4.0. He is basically the ultimate father is this Professor Wolfgang Waschler. He was the one who came up with the report, Industry 4.0 with the Internet of Things on the way to Fourth Industrial Revolution. This dossier or this document was produced to the German government, and then this article came out in Germany in 2011. But Professor Schwab, he wrote the book The Fourth Industrial Revolution in 2016. So this is the one of the earliest document on Industry 4.0 and also IR 4.0 in 2011. In 2011 here. Okay, so these are the elements of IR 4.0. I think everybody knows about it. This is very, theoretical and based on the perspective of the user who sees it. Some people say there are 11 pillars of technological advancement for IR 4.0. Some people say that there are 9 technological pillars for the IR 4.0. I would tend to agree more on the 9 pillars because this is one of the most heavily used. We have autonomous robot. Everybody knows that robot is a system that operates on its own. It can be a physical robot. It can be a software robot. We already have, and the physical robot can be in terms of autonomous ground vehicle, autonomous air vehicle like drone, or autonomous underwater vehicle. We can have humanoid type robot. We can have industrial type robot. It doesn't have to come in the form of C3PO like or Asimov only. It can come in many forms. And then the cyber security part of it, very important. Big data, or as everybody aware, a veracity of data, velocity of data, volume of data. The 4 V's or the 4 elements of big data. We have the augmented reality, whereby the fusion of virtual reality into the real physical reality that we have. And one of the best example of augmented reality, I always bring that to several talks that I given, is the Pokemon Go games. That is, you want to explain what is a virtual reality? Easiest, you just ask if they know Pokemon Go, then you can explain them very easily. And it's a very famous game. I think a lot of kids or even adults play that nowadays, whereby we to combine the virtual reality with the physical reality, utilizing the augmented reality. You catch the monsters and then bring your phone here and there around with your friends to catch them. The more you catch, the higher level you get. Okay, then we got the cloud computing and additive manufacturing, basically 3D printing, simulation and digital twin. Also, in the Internet of Things, these 2 things is very important. The Internet of Things, people always associate it with IR 4.0 because it enables the connectivity between the systems, between the devices, and also system integration. Sometimes people forget about system integration. All of these, you see, autonomous robot, cybersecurity, augmented reality, cloud computing, additive manufacturing, simulation, the Internet of Things will not work without system integration. This is where this is one of the most important pillars for IR 4.0. We can have vertical systems, or we can have horizontal systems, like for example, like in terms of a software system like Microsoft Word, PowerPoint, Excel, everybody knows that. Or you can have a very vertical system like you have Primavera, you have SciTech, you have Wonderware. These are kind of softwares or things that only certain people will use. Not everybody use it. So these are very horizontal kind of application or a horizontal kind of system. So in system integration, there's a big integration between these horizontal systems and vertical system. They are integrated together. You do reporting using Microsoft Word, extracting the data from Primavera or extracting the data from Wonderware, which is a SCADA or supervisory control and data acquisition system. You combine them, and it enables other systems within these pillars to be interconnected. And wireless, I cannot emphasize enough on the system integration and also the connectivity here. When wireless is perfectly applied, the whole Earth will be converted into a huge brain. And the instrument through which we shall be able to do this will be amazingly simple. And when the wireless world is applied, the whole Earth will be converted into a huge brain. Instrument that we use to achieve this is going to be very simple. A simple and inexpensive device, readily carried about, will enable one to receive on land or sea the principal news, hear speech, lecture, song, play music, convey from any other region of the globe. What does you think this statement refers to? Anybody wants to just what does this statement refers to? What does it refers to? Wireless, yes. Other than that, what does this statement? What is the device that this statement is referring to? You guess. You might guess. What will be the device that can do this? IoT sensors, some more. Mobile what? Mobile phone, yeah. I was thinking the answer. Mobile phone. Your mobile phone is the most powerful mobile device or connectivity device available currently. You can talk to other people. You can talk to machines. During the recent COVID, we use phones to allow the students to do experiment in their home, because from the phone you have a lot of sensors. You have proximity sensors, you have sound sensors, you have light intensity sensor, you have vibration sensor. Every sensor is there in the phone. So it's a very powerful device. And can you guess whose statement is this? Who said this? Can you guess who said this? About this smartphone. Who said this? I just want to know. Can you guess who said this? Who said this statement? Whose statement is this? Can anybody wants to guess? Microsoft. Okay, come on, some more. Thomas Edison. Okay, come on, some more. Who said this? Nokia. Okay. Apple. Okay. Okay. Some more. I have two screens, so that's why I'm looking at the screen. Anybody wants to try? Huawei, Prime Minister. Whose Prime Minister is that? Okay. Bill Gates. Okay. Simple and expensive device, mobile phone. Okay. Bill Gates. Come on. Mr. Washikin, you want to try? Isaac Newton. Okay. This is nothing right or wrong answer. It's just something that we want to appreciate, kan? Let's see whose statement is this. If you were in a physical conference, perhaps we can give a prize for those who can answer. Okay, Mike, because we don't have much time, we have other segments to go. Mayun, okay. Okay, right. This guy said that. Simple, inexpensive device, readily carried about. Enable one, so say yes, Nikola Tesla. And yeah, of course, you know when he said that, 1926. He is such a revolutionary man. So, okay. Right, the connectivity, somebody has predicted that connectivity is very important. That's why changing of the industrial revolution from one industrial revolution to another industrial revolution is not a simple matter of saying we are now in IR5, we are now in IR6. It's not something like that. You have to have a fundamental you have to have a fundamental shift behind before it can move. But of course, there are other things to be considered. I don't know, maybe if the push for sustainability is too big, perhaps IR 4.0 can become IR 5.0 just because of sustainability. But I don't know. But to me, the fundamental change must be there. And this guy is just brilliant. Okay, so we have the Industry 4.0, we have the smart city with all the connectivity. You can see if you talk about 4.0, everything, it must have this line here, connectivity, and connectivity. Okay, and it's so important that our government has introduced two policy. Now, one is Industry Forward in 2018 by MITI. This one focused on Industry 4.0, and recently in 2021 by the JPM, Jabatan Perdana Menteri, and EPU, and also MOSTI, that is more general. Dasar Revolusi Perindustrian keempat, fourth industrial revolution policy from our government. And at the ASEAN level, we have the consolidated strategy on the fourth industrial revolution for ASEAN. This is done by the ASEAN Secretariat end of last year. We are in collaboration with these people from the ASEAN. We are supporting one of the research institute over there called the Economic Research Institute of ASEAN to support the ASEAN Secretariat. Right. So having said that, we now know about the IR 4.0. We know about the sustainable engineering. How does this can be used in order to how can IR 4.0 be used for the benefit of sustainable engineering? We know that we need the enablers, and therefore the IR 4.0 is the enablers here. I don't put Industry 4.0 as the enabler there, because for sustainability is not only for manufacturing. It can be for environmental, it can be for food production, it can be for, I don't know, building, smart buildings. So that's why the basic guiding principle is not Industry 4.0, but it's the IR 4.0 itself, the main framework. So we see that industries using digital twins to drive sustainability in oil and gas operation. You can operate the oil rig first without having to build it. You can save a lot of money. Simulation is very important. You want to simulate nuclear reactor failure, for instance. You don't want to create a nuclear reactor and then make it fail. We can simulate it. So that's why we are using digital twins, and digital twins is part of the main pillars for the IR 4.0. And also Google's are using data analytics. Data analytics is also part of the IR 4.0. And we have augmented reality and virtual reality. There are researchers who are doing augmented reality and virtual reality to show what will happen to this Earth. For instance, the project climate change. Because this is also a bit related to the digital twin, because we are not experiencing climate change yet, the excessive ones. But let's say you want to show that if we don't fix this problem, if the water level keeps on rising to some certain level, the Earth will become something like this. That one, we cannot show them immediately because that thing does not happen yet. But we can simulate it in a virtual reality and augmented reality situation. And also on the IoT and sustainability part, our team, my team from UKM, also from our startup, Innovative Solutions Berhad, we provide solution. We develop solutions utilizing IoT. For instance, some of the application, network and facility monitoring system at Putrajaya. This is one of our biggest systems since 2011, 600 sensors in real time. This practically was my PhD project initially. Once it was successful, then I licensed it to the PhD project. The output of the PhD project was licensed to a company called Innovative Solutions Berhad. So they took it from there in 2011 and then make it successful until now. Right, so this is the topology of the systems, and then we have the hydrological monitoring system in Putrajaya Lake and Wetland. All of these systems are locally developed by our students and researchers graduating from the lab. So basically, in every picture that you see, you will see lines here, connectivity. We develop our own remote terminal unit and also IoT nodes and gateway, and we are doing water balance and also water prediction for the lake in Putrajaya. These are all connected and collected using the IoT nodes and gateways. Some of the monitoring station, also pump house operation. Also previously there was a lot of problem because students don't have water because pump not working. Now not solved already. We also have air pollution. So these are some of the examples of the solution for sustainability, which was contributed by IR 4.0 elements. Smart sensor monitoring in Dubai. This is our system in Dubai and in KL. And intelligent energy monitoring, this is something that we are looking into right now. We developed the energy meter, wireless energy meter, transfer data to the cloud. You can analyze whether you can see from here what you need to measure things first. After you measure, you can do analytics and prevention. You can see that during the MCO, motion control order, the electrical energy, there's a saving in the electrical energy because people didn't come to work now, right? So maybe we can translate this. If let's say my boss say that half of the people can work in the house today and next week the other half will come, you can save a lot of electricity in the office and a lot of money in that. Well, that's all the technology that is available there to help us make a sustainable, implement sustainable engineering project in order to make this world more sustainable. I hope my hometown will stay something like this, even for the rest of the age of this earth stays like this, because it's very, calm and serene to look at that. I don't want to have too many buildings, and I don't want we have to have too many buildings to support the living. Right. Okay. Based on that, I would like to thank you everybody for your participation, for your attention. Thank you. If you have any question, I will please just pose it. Okay.
Thank you very much, Dr. Hanif, for the speech. We will now open our session to the floor if there is any question for Dr. Hanif. Audience may use the raise hand feature or write the question in the chat box. Is there any question from the floor? Yes, Mr. Nawaid, please proceed with your question.
Assalamualaikum, Doctor.
Waalaikumsalam.
Doctor, as you have talked about this sustainable, so MMU has supported it a lot as under the supervision of Dr. Azlan and Prof. Tang. And I think I have also seen you in Myson Roundtable. And in three roundtable he arranged for this sustainable, and the fourth one will be coming in which they have discussed. So my question regarding this sustainable is that uh, can we say that sustainable this engineering is like a part of the reverse engineering that we can use, like the example you have given, very nice, the air sucker that convert into the jewelry reverse order in the same manner. So can we say that this is a part of reverse engineering?
Um, Thank you, Mr. Nawait, for that question. Whether it's a direct design, new design, or reverse engineering, that is the technical implementation of it. Means that I want to reverse engineer a product. Of another example, if I go to a factory, I have a machine, an old machine. I want to retrofit it with sensor to increase its capability, or whether you want to design a new product. That is practically on the technical layer. Technical layer. The sustainable engineering, I would say it goes on the higher level than that. It's on the guiding principle. It's the guiding principle. Why you want to reverse engineer something? Let's say you have a car, you want to reverse engineer, you want to make it in better consideration, better condition. For instance, why you want to reverse engineer? Because you want to study it, or perhaps you want to improve it. Why you want to improve it? Because you want to make it something that supports the SDGs, the Sustainable Development Goals. How you do it, that one, it up to you. The sustainable engineering is just a sustainable engineering practice. It guides you how to do. It guides you how to do things, but not on the technical layer. Okay, so, for example, I want to design. I want to design a new. I want to design a new house. So designing the new house requires my engineering knowledge. I have to do this, do calculate this and that. That is on the engineering, on the technical side. On the higher side is I need to do it sustainably. So rather than, let's say, I want to use some materials, this material is not good to the environment. I have to change that material with some other material which are environmental friendly. So the sustainable engineering gives you a guidance on how to implement it, but not on the technical basis.
Okay.
You get that?
Yes.
Thank you, Mr. Noy.
Sir, one more question, if you don't mind.
No problem.
Sir, if everything, I'm thinking if everything will be automated, so what do you think the impact of this sustainable engineering at the employment rate? I mean, if everything will be done by machine, so the worker will employment will be affected, impact or not?
Okay, I can maybe give some controversial answer that. Okay, suppose it like this: we have a factory. In the factory, we have 1,000 people working as the operators. So these
Mm-hmm.
operators, they do manual work, means that they pick up something, assemble something. With the advance of automation, perhaps 600 of these operators, they can be replaced by machines. It is not something that we say we don't want that to happen. It will happen. Automation will come, it's already there. The 600 people will be terminated and be replaced with machines. So the thing is that for us to embrace that, it's not to say that, okay, we terminate you 600 like that. No, we have to take the 600 people, perhaps we have to retrain them so that they can have a higher level of knowledge and they can do work which require higher level of knowledge. So this is what is happening with reskilling and retooling of our workforce, It happens everywhere. I have a it needs to happen to everywhere. We need to, we need to increase the level of thinking skill and competency for our people so that they become better and better. We cannot say that I want to stay like this. No, automation is coming. Any work that is repetitive will be replaced by machines. So we have to increase your thinking skill so that I can assign you a more creative work for you to do. So it's not a problem of no work anymore. There's still work, but different type of work. Yeah. Thank you.
Okay. Thank you, sir.
Thank you, Dr. Hanif, for the explanation, and Mr. Nawaid for the question. Is there any more question from the audience? Okay, I assume there is no more question from the audience. So we have reached the end of the session. But before we dismiss, let us turn on the camera and take a few snaps. I'm going to give you 30 seconds to prepare. Okay? And please turn on your camera. Dr. Hanif, perhaps you can stop sharing the screen.
Okay.
Thank you, Doctor. All right. I'm going to count until 3 before I snap. Okay, ready? All right, 1, 2, 3, snap. Okay, just a moment. Let me see the pic. Okay, let us have one more time of picture. Okay, 1, 2, 3, snap. All right, this one is great. Very nice. Thank you very much.
Thank you.
Yeah, thank you. Thank you very much, Dr. Hanif, for the valuable sharing and honoring us with your presence. We have some token of appreciation for you, and it will be posted to your office very, very soon. In the meantime, let us enjoy this virtual token of appreciation from us. We now know how important sustainable engineering is, especially its contribution towards IR 4.0. Thank you again, Dr. Hanif. To the audience, thank you very much for your unwavering attention and your well-thought questions throughout this session. See you again next time. Stay safe and have a good day. Bye-bye.
Bye-bye. Thank you, everybody. Thank you, everybody. Thank you.
Thank you. Thank you, everyone.
Thank you.